Okay, so let's have a look at the Leaving Cert Higher Level Maths Paper 2 for 2018, question 6. So question 6 is a geometry question. The first part here involves one of the proofs that you have to be able to write out. So we have, let's see, let ABC be a triangle. Prove that if a line L is parallel to BC and cuts AB in the ratio S to T, where S and T are elements of N, then it also cuts AC in the same ratio. So basically you've got a triangle, and the triangle is ABC. Now you have a line here. This is the line L, which is parallel to BC, so these two lines are parallel. This is the line L here, and it cuts AB in the ratio S is to T. S is to T here, and T is a natural number. Then we've got to prove that it also cuts AC in the same ratio, S is to T, as well. Okay, so let's start. So we usually do these proofs by doing four things. We write down what we're given, what we need to prove, we need to do a construction if there is a construction, and then we write out the actual proof itself. So let's start with what we're given. So we're given a triangle. We're given a triangle ABC and a line The line is x, y. So this is x here, and this is y here. And this line is parallel to BC. And so we have a triangle ABC and a line XY parallel to BC, which cuts AB in the ratio S is to T. So this is what we're given. So next thing we write out is what we need to prove. Okay, so what we need to prove here is that the distance from A to Y to the distance Y to C is also in the ratio S is to T. There is a construction, so we'll do that as well. So our construction is to divide AX. So we're going to divide AX here, from here to here, into S equal parts. And also, and XB into T equal parts. So we're going to divide into equal parts here, S is to T. In this case I've got 3 is to 4, but it could be anything really, depending on what S and T happen to be. So we're dividing them into this distance here into S equal parts, this distance here into T equal parts. Through each point, so through each point of division, we're going to draw a line parallel to BC. So what we end up with here is, I'll do it in a different color here. So I'm going to draw a line across here, a line across here. All of these are parallel to BC, and we're going to do the same here. So we're going to draw a line across here, here, here. So all of these lines are parallel. Okay, so next part then, that's our construction. So next thing we've got to do is write out the proof. Okay, so I'm going to start by saying the parallel lines cut off, they cut off equal segments or cut off segments, I should say. We'll do that again. Cut off segments of equal length along AC. So we've got equal, these are all equal divisions all the way down along here. This is true because of a previous theorem we did, Theorem 11 actually. So we have two parallel lines and we have a transversal. The transversal is cut off into equal segments. I know it doesn't look like it here, but it is. And therefore any other transversal will be cut off into equal segments as well. So this was a previous theorem that we actually did. So we have equal segments all the way down along here. So all of this is equal to this, equal to this, equal to this, this, and this. These are all equal segments all down along here. Okay, so the parallel lines cut off equal segments of equal length along AC. This is previous theorem. So we're going to say let K be the length of each of these equal segments. So in other words, if we come back here again, we can say that this here is K, this is K, this is K, 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 and so on. These are all K distance from here to here, from here to here, from here to here, all K in distance. So K is the length of each of these equal segments. So that means then that the length AY is to, the length AY is equal to S times K. So the length from A to Y, the length from here to here, is K multiplied by S, because remember we've divided this up into S equal segments, S number of equal segments. So if each one is K length, K units in length, then the distance from A to Y is S times K. And similarly here we're going to say the same down here. The distance from Y to C is going to be K times T, because remember we've divided this distance here and this distance here into T equal segments. So the distance from Y to C is going to be K times T. So we can say then the distance from Y to C is equal to K times T, or T times K. So that means then that AY, the distance from A to Y, is to YC, this particular ratio here, is just going to be equal to SK is to tk, this distance here. So we can divide these two by k, and that just gives us s is to t, which is exactly what we needed to prove. This is what we had written down as what we needed to prove. So I'll just write down QED here at the end, which is Latin for that is what needs to be proved, or that is what is proved. So we have finished part A. That's part A finished. That's our theorem. There is another section down here somewhere. Oh yeah, so this is part B here. We've got a triangle here, which is related to what we've just done. So let's see what we have. We have a number of triangles here actually. In the triangle ABC shown below, the angle CAB is 90 degrees. So this angle up here is 90 degrees. AX is 4, so we have the distance here is 4, and AY is 3, so we have a distance here of 3. XY is parallel to BC, so this line here is parallel to BC, so similar to our theorem. XZ is parallel to AC, so this line here is parallel to this line here. So again, that's our theorem. If we turn this triangle clockwise, roughly 90 degrees anyway, you'll see we have another triangle similar to what we did previously. Now the ratio AX to XB, so that's AX to XB is 1 is to 2. 1 is to 2. So immediately we could write in here the distance. If this is 1 is to 2, if this is 4 here, this distance here is going to be 8 centimeters. If this is 4 centimeters, this is 1 is to 2, so this distance has to be double that, so this is 4. Or sorry, this is 8. 4 is to 8 is the same as 1 is to 2. Also, you can see here, based on our theorem that we've just done, we also know that if this line here is parallel to BC here, which it is, we've been told that in the question, and this is in the ratio 1 to 2, then AY is to YC is also in the ratio 1 to 2. So this also is in the ratio 1 to 2 as well. So again, if this is 3, this here must be 6 centimeters. So we've got a few measurements in there already without even reading what we have to do. Also, by the way, you can see we have a right angle triangle here. So using Pythagoras' theorem here, we know that this should be 5 centimeters here. It's basically the first Pythagorean triple, 3, 4, 5. But you can do it very quickly anyway if you're unsure about that. 3 squared plus 4 squared is equal to xy squared. So this here, 9 plus 16 is 25. That's xy squared. That would give us xy as the square root of 25, which is 5. But you should have spotted anyway that it's a 3, 4, 5 triangle here. So we have a number of measurements here that we could just write in very, very quickly without thinking too much. So what do we have to do here anyway? Let's read the actual question. So we have to find BZ. So we have to find this distance along here. Okay, so there are a number of ways of doing this. Let's just have a look at one way of doing it anyway. Let's see. We could find BC anyway. We can find the distance from B to C. Again, by just doing Pythagoras' theorem. We have this length here. I'm looking at this big triangle here. So we have AB and we have AC. So let's just quickly do that. We have AB, which is going to be 8 plus 4, which is 12. So that's going to be 12 squared plus 6 plus 3, which is 9 squared. That will give me BC all squared. So 12 squared then is just 144. 9 squared is 81. So that will give me BC squared. 144 plus 81 is 225. That gives me BC squared. And let's see, the square root then, BC Square root of 225 is just 15. So BC is 15 centimeters. So now I know the distance along here. Okay, so how will that help me? Let me see. We can use ratios of sides then. We have, let me see, we have 15, let's see, we can say 15 over BZ, so we can say 15 over BZ equals 12 over BX. Yeah. So if you turn this triangle around, so it looks like this. I'll just draw a smaller version of it here. So let me see. We have C here. We've got A here, and I've put the B up here. This is our right angle here. So I've rotated this around clockwise. What will I end up with? I know that this is 15 along here. I know that, let's see, I've got BX is here, and this is Y, by the way, so BX is 8 centimeters, AX is 4 centimeters, and let's see, what else do I have? AC, so all this distance along here is 9 centimeters. So I can do ratios of sides here again, because we know that XY is parallel to AC. So I could say 15 over BZ. Let's see, where's Z here? Sorry, this is X, this is Z here. I should have a Z here. Let's see, this is actually Z here. I should say, so 15 over BZ is going to be equal to 12 over 8. So what I've done here is I've said this distance here divided by the distance we're actually looking for, which is BZ, divided by this distance here, that's going to be equal to this distance here divided by this distance here. So sides are in proportion again, so ratios of sides here. So I have an equation here with just BZ in it, so I can cross multiply here, so this will just give me, let me just start that again. So we're going to do 12 times BZ, distance BZ is going to be 8 times 15, so that will give me BZ here is just equal to 8 times 15 divided by 12. When you do that, you get 10 centimeters. So BZ is equal to 10 centimeters. Okay, so we finally got there. Now there is probably a shorter way of doing that. Let me just have a look here. Yeah, what we could do here possibly is just take this triangle here and slide it down along here, so that we get this triangle along here. So this was still a right angle. This angle will be equal to this angle here, their corresponding angles, and this angle here will be equal as well. Let's give it a different, let's call it X here, or let's call it maybe just call it beta here, or something like that, just something different anyway. So these angles are equal. So these are this triangle and this triangle here are going to be exactly the same size. Now if you look at this, we are told initially that, let me do a different color again here, let's do blue here, we'll do green I think. So we know that this here is to this here is 1:2. This is 1:2. I've just moved this side down here. This is 1:2. So if that's 1:2, then this here is going to be 1:2 as well. That's going to be 1:2, and also this here is going to be 1:2 here. 1:2. But we already know that this side here is 5 centimeters. So that means BZ here is just going to be double that, which is 10 centimeters. So that's another way of doing, probably a shorter, simpler way of doing it. Okay, so that's it for question 6.